Um, Please welcome our next speaker, Harsha Hampapura. Is that right?
All right. Hi, everyone. I'm Harsha. I'm an associate scientist at the NSF National Center for Atmospheric Research, and I'm here today to talk about our efforts at integration of NCAR's data infrastructure with the Open Science Data Federation. Do have to close at 12:30, right? Okay. Right. Okay. This collaboration is supported by NSF's pilot effort called the National Discovery Cloud for Climate. I think we are dropping the C, and we'll just call it NDC under current circumstances. Um, but this pilot effort so the whole goal of this pilot effort is to develop a national scale cyber infrastructure to support climate research and education. So that's the outline of my talk. I'll quickly talk about NCAR's data infrastructure and the various repositories, how we are trying to pool them all together into a single data commons. And I'll talk about the progress that we have made in our collaboration with Open Science Data Federation in the past year. And if time permits, I'll talk about some workflows and the challenges we face while we try to run them on the OS pool. So under the banner of NDC, our goal is to broaden community access to NCAR's data beyond our expert users who are already familiar with our data repositories. And this includes model output, observations, reanalysis, and this is to support climate research, obviously, and especially extreme weather research. Another of our goal is to train researchers to use the capabilities of the National Discovery Cloud, this infrastructure, to run a variety of workflows on different computational platforms, and along the way, access data from multiple OSDF origins, including the NCAR and other data origins. Okay, so a lightning introduction to NCAR's data repositories. Even though it says atmospheric in the title, we have 8 labs and programs that perform research on a wide range of topics. You name it, starting from the effect of sun's effect on Earth's atmosphere, the role of oceans in weather, helioscience, meteorology, etc. And we also work on educating the next generation of scientists. One thing that's not on the slide is we are also engaged in translational computer science. So we end up building software that's loved and used by the geoscience community. Obviously, all these labs and programs end up creating a lot of data, which are archived in multiple data repositories. Why is it this way? Historical reasons. Some of them are Geoscience Data Exchange, the Climate Data Gateway, Research Data Archive, and we have a data catalog in which you can search for data sets on some of these repositories some of the time. So we serve 2 main class of users. The first are obviously users with NCAR HPC users who have HPC accounts, and this doesn't have to be NCAR staff. Anybody can get an account. They have direct disk access to some of these data sets, but it's not great because you don't have access to all possible data sets, and there is no good way of looking for the data short of asking your colleague, hey, what is the path to this object? The other set of users we support are remote users most of whom follow what we call the download and analyze model, right? So if you look at the graphic, they first have to go through one of those dataset repositories, find the data of interest, and download tens of hundreds of files in bespoke formats, and clean them, organize them on their local disk, and hopefully get to the stage of analyzing this data. And this is, needless to say, this is time consuming and efficient. Nobody wants to download hundreds of GBs of data onto local disk. They should be streaming it. And there's another problem. User experience can be extremely heterogeneous depending on which data repository you're accessing data from. So those are all the problems and challenges we have with serving data. So our vision is to simplify data access, and we are calling this the data commons. And our goal is to satisfy these basic three requirements. One is we want data to be accessible to everyone, starting from novice users to expert users in a consistent fashion. We want the whole ecosystem, data access ecosystem, to be integrated with the tools that are used to access this data, including the zoo of ML models that are coming up. And all of our data is open access. So, and we support open science. So we want any community cyber infrastructure initiative to be able to plug into this data commons and use our data and share their data with us. So if you look at the graphic, you can see all those dataset repositories within one blob. That's our data commons. And we can interact with other data providers on the cloud. And we would want to serve our on-prem users who have HPC accounts. And on the right-hand side, we have our remote users, some of whom will invariably end up downloading files, but we are urging a lot of them to move to the streaming regime where they just stream the bytes that they want to analyze. So it's only natural that we would collaborate with OSDF. I won't dwell a lot on this slide. Obviously, OSDF is a great resource to democratize access to data in a performant fashion that scales. So what have we done so far? In the past year or so, the big achievement has been to deploy multiple origins. We have multiple origins because we have POSIX data storage system. We also have an S3 based storage system, and we have also installed and deployed cache. That's quite beefy. And in March of this year, we turned on data access, and now petabytes of data from the research data archive are accessible to the Open Science Data Federation. And in the climate science community, people love Python, so they love this package called Intake. And Intake ESM is a plugin for Earth system model data. So they like accessing data this way. So in order to support that, we have published several catalogs as well. And these are also backed by Pelican. So just to give you a glimpse, if you go to any of our data sets and go to the data access tab, you will see a web file listing of all the files that are available. This is powered by OSDF. And if you click on the links, it'll show a link like the one on the slide that's aware of the OSDF director. Sorry about the dark background on this slide, but once we turned on data access, we saw some interesting access patterns. A majority of our users are from China. So that's NCAR data flowing through the OSDF cache in Korea to them. The other mode of access we support, as I said, is catalog-based access. So on the data access tab, if you move to analysis ready access, which is basically When we say analysis ready, it means that we have done a lot of pre-processing so that users don't have to regrid the data, clean up the data, add units, etc. We have done all those steps. They get access to 3 different catalogs. There is a POSIX catalog for our on-prem users. There is a basic HTTPS catalog for users who want to just load files using basic HTTPS access. And there is a OSDF powered catalog that uses Pelican FS to transfer data into users' workflows. So just putting it all together in this diagram. Yeah, so there's a data commons. A remote user would use the orange arrow pathway where they would use a POSIX based catalog and load data into their workflows that's running on Casper or Derishow, which are our HPC systems. And the remote users would stream data that they discovered using a different set of intake catalogs. And that's powered by Pelican FS, which is Python implementation of the Pelican client. And I would like to take this opportunity to thank the Pelican team, especially Emma Turitsky, who built Pelican FS and allowed me to be the first guinea pig. Okay, so much about data access. Let's see some of it in action. So in order to encourage Earth system scientists to use this new infrastructure, we are developing several workflows, and these are all open access and published on the GitHub repo there. And this collection will keep growing as long as NSF funding keeps flowing. So I'll talk about one of them that Brian touched upon in his talk as well, just to show that we can access data from multiple origins. So people run in geoscience community run global climate models and store data from multiple models. And this is stored on AWS. And we have some observations stored on the NCAR origin. In the example that I'm going to discuss, I'll gather temperature data from these 2 different origins and plot global mean surface temperature change. Brian talked about it, so I'm not going to dwell on this slide a lot. So obviously there are binary blobs of data sitting on different data repositories, and you have origins next to them. And if you're accessing it for the first time, it'll come to the cache closest to the user. And yeah, it's transferred. So I've been talking a lot about catalogs, so I just wanted to give you a glimpse of how it works. So on the slide, I have a query for requesting data for multiple forcing scenarios. Those are the experiments. I'm requesting data for a single variable on monthly frequency and from a single ensemble member. So if you try to retrieve this data by composing namespace and object paths, that would take a long time, right? But if you pass this query into the intake catalog, you get a subcatalog, and the user doesn't have to know any file paths and can just pass this subcatalog into a package called xarray, which is very good at dealing with n-dimensional labeled arrays. And we use another open source Python package called Dask to scale up our computations. But if you really want to inspect the paths, you can go ahead and you'll see that it's backed by OSDF. I'll skip this. Here's the plot. So what you see there is in green is the intermodal spread of global mean surface temperature change, and the purple and orange curves correspond to model outputs for different forcing scenarios in the future, depending on how much carbon dioxide we release into the atmosphere. And the red dashed line is the observations. So the user did not have to know anything about where the data was sitting, what the object paths were, right? And they could get to it. And in the last minute I have, I'd like to pivot and ask, what does it take to run this exact workflow on the OS pool? Obviously, we can, the Python ecosystem is there. There's the Jupyter notebook hosted on the OS pool. It's fantastic. and we can submit batch jobs. But the climate data science ecosystem has come to love this tool called Dask, which does the parallel scaling for you, right? So it basically ends up creating a DAG-directed acyclic task graph, which is executed by the Dask scheduler. But unfortunately, we cannot run it on the OS pool right now because the Dask scheduler requires two-way communication between the workers and the scheduler. And this is a classic problem of portability of a workflow. So check out Doug Thane's talk where he tries to solve this problem. Thanks. Questions?
Thank you, and it's really wonderful to have NCAR here. That's, I think, a milestone for our community to have you attending HTC. So welcome.
Thank you.
I think it will be good to think about how not to talk about origins, but to talk about the namespace. So rather than saying there are multiple origins, to talk about the NCAR namespace in OSDF, because the origin is just a way to access object in a certain part of the namespace. So we should have a discussion about how, at your level of the presentation, it is not an origin, but a node in the NCAR OSDF namespace.
Okay, I stand corrected. I'll learn about it. I think there are multiple origins that are mounted, but yeah, if that's not the case, yeah.
For a researcher perspective, they should not hear anything about things like origins. It's just a mean to bring object for a certain element in the namespace of NCAR in OSDF.
Yeah, sure.
So we've been hanging out with various domain science communities for a while, and we've got their lingo down, and we've got their lingo down to some extent. One thing that we don't hear as much about are things like catalogs and things like intake, or new jargon for us. What are, from kind of your perspective, coming from the Earth systems climate side, what lingo or jargon of ours did you have a hard time with? What things sounded foreign or didn't translate well to you when you were beginning that you struggled with, where we can do better about explaining what we do in throughput computing to the Earth systems community?
When I was trying to get spun up, I guess the concept of how exactly the data is transferred, that was a puzzle, right? So is it copied to the cache and then transferred to my laptop or wherever I'm working? So I had to go through that a few times to understand how data is delivered. I didn't touch upon cloud optimized access. So as you know, the geoscience community has built some bespoke file formats for hierarchical data access where you can just stream individual bytes. So how does XRootD work in tandem with this? I guess that's the piece that people want to know. I'm not sure if geoscientists would be concerned about it, but yeah, like technically minded geoscientists would be concerned about it. Yeah.
All right, thank you.